Hello everybody, today we will see briefly about the basic linear and biased predictor stability analysis using RStudio. So there are a number of statistical analytics has been developed to estimate genotype by environment interaction under multi-location trial. And there are two popular methods has been used widely. The first one is additive main and multiplicative interactive analysis, while the second one is the basic linear and biased predictors. So the first one, it means the additive main and multiplicative interactive analysis considered the fixed effect of genotype under linear model, while nowadays it should be reasonable to consider genotypes, environments, or both. That means their interaction to be random effect in a mixed model approach. So, in order to answer such type of question or such type of worry, the basic linear and biased predictive it is very essential. It's very essential because it provides the potential to improve the predictive accuracy of the random effects. So it is very good. Comparing to that one, for example, the additive main multiplicative interactive analysis, it's retained most of it is G by pattern in the first interaction. Principal component axis, while most of the random error had been explained by the last interaction principal component analysis. But in this case, that means in the basic linear and biased predictive method, it estimates the effect of ANOVA model and then attribute weight to this effect, and it could thus be considered as a shrinkage estimator. So we will see briefly about the basic linear and biased predictive model for multi-environmental trial, multi-environment location of trials. So it should be run, first you have to run, since it is BLUP is based on the package called methane, so type this one and run, and if you don't have, you have to install from the internet source. So the function here is the gamete. It is used to fit the linear mixed effect model, and the first argument that coming into this parenthesis is the data, then it's followed by the environment, genotype, and here is also replication, and again and lastly here is the RESP. That means it is the response variable that are going to be analyzed. So the function allows a single variable. In case, for example, if you have grain yield, you can type GY, and also here we'll use everything. That means to analyze all the numeric variables in the data. And here by default, the genotype and genotype versus environmental interaction are assumed to be a random effect. But in case if you want to consider or to add as a random effect, you have to type random, and also here you'll add additional random effect variable. And the last one, that means the purpose, it is control if the code is run silently or not. So you can give any name that you want here. So I typed here is Wago, and write all things that you see here in the screen, then run. And again also it will give you a result. For example, genotype as well as genotype versus their interaction it is highly significant for both the grain yield and the hectoliter mass. So it is a very good result. So we will further also diagnosing our plot. For example, whether it is fit, whether it is violet or not, especially the assumption. So to do that, the accessory generic, that means generic function, that means the plot it is used to generate diagnostic plot of the residual of the model. So type plot and write the name that you give here is WAGO. So it will give you result, and it will display on the right corner of our studio. So it will show you whether the assumption is violated or kept. So if you want more explanation and detailed information about such conditions, you have to refer my previous tutorial regarding to the assumption. That would be your assignment to refer my tutorials. So this is about the diagnosing of the model. So if you want just to test further, if you want to test the normality of random effects of the genotype and their interaction, effects may be also used by obtaining you have to type RE. So plot, then the data, the object that we assign here is WAGO, then type, and here is RE. So it will give you again other graphs for further diagnosing among the genotype and environmental interaction. So this is also the other result. And again, if you wanted to printing the model output, for example, if you want to check the likelihood ratio test, and you have to type any name that you want. Here is MR, and also the likelihood ratio test is used. The function it is get model data. So here is WAGO that we generate here, and LRT means is likelihood ratio test. So type this one and run. So it will give you the genotype and genotype, their environmental interaction. So again, run this one. So it will give you for both grain yield and hectoliter mass, the genotype as well as genotype by environmental interaction is highly significant. So by this way, you can get your likelihood ratio test. And further, if you want the output estimate beyond the variance component for the declared random effect, some important parameters, if you want to run some important, especially variance component genetic parameters, in order to do that, you can give any name that you want here and use the function get model data and type the WAGO. That means that we generated earlier, so type this one and run. So it will give you the print heart. So it will give you the phenotypic, heritability, and coefficient of variation for the residual, for the genotype, the accuracy. So it will give you a detail for the variance component and genetic parameters. So you can also discuss further by looking this method. Even also CV ratio, it is a ratio between the genotype and the residual coefficient. And again also it is CVG and CVR, that means the genotype coefficient variation and the residual coefficient variation. So it is very important. So you can also a chance to analyze using RStudio. Then the next one is plotting. If you want to just to plot the basic linear biased predictive. For example, if you want for genotype, so you have to type print and WAGO among the attached grain yield, and from the grain yield, then you have to type this syntax. So you will get again a result from the console. So again, it will give you more detail about your genotype. So if you want to plotting the basic linear and biased predictive for the genotypes, so we can call the library ggplot2 like here, and again you have to give any name that you want. So let's say here is A, then plot BLUP, then type WAGO. So it will give you result. Before that, let me arrange if you further want to classify, or if you want to change especially the x-axis to y-axis, you can use a coordinate flip, but let me briefing. So let me brief it. Plot, BLUP, then WACO, and you can give any type of color that you want. Maybe it's blue, maybe it's red, maybe it's green, maybe it's pink, but whatever you want. And also you can assign the plot term. So, and again, also here is the coordination flip. For example, if the green is in the x-axis and if the genotype is in the y, so you can change it, the position, vice versa. So type this one on your RStudio and run. So let's arrange this together, both levels. For example, arrange ggplot A and B, and the tag labels as A and also as B. So type this one and run. So you will get this result. So based on this result, for example, genotype 8 and genotype 3, they are beyond the mean level, as you see here, beyond the mean level. So they contribute highest green yield and is more stable comparing to the G10, comparing to genotype 9. And in similar fashion, G2 and G7 also, it is next higher than of G3 and G8, but it's more is approach to the G4. So by this way you can interpret your BLUP in the basic linear and biased predictive analysis. So it will show you the stability in this manner. And again, if you want to further analysis their genotype by environmental interaction, you have to type this one, print, then WACO, and from the green yield, then basic linear and biased predictive interaction. So if you type this one, it will give you some result, especially with their interaction effect. So this is all about the basic linear and biased predictive. So for the coming video, we will see the WAS method, what it looks like, and its structure. So as usual, if you have any question, you can address me through my email, wabdiratasfahun at gmail.com. So thank you for watching. Please share, subscribe, and provide your valuable comment on on YouTube comment box or through my email. Have a nice time. Goodbye.